Okay, this is my solution to the problem that we did on Wednesday of week 2. So the problem is about swimming across a river, and so a person is standing on one side of the river and wishes to reach a lovely beach, a tree on the other side of the river, and so the person wants to cross directly across the river. However, there is a current across the river. And so the idea here is that in order for the net vector to be this way, with a velocity vector going this way, the swimmer is going to have to swim this way. So the swimmer with respect to the water plus the water with respect to the land equals the swimmer with respect to the land. So this is a additional velocity problem, and so formally we would say the swimmer with respect to the water plus the water with respect to the sand, or the land, or the beach, whatever, equals the velocity of the swimmer with respect to the sand. And so the problem says that the current, the speed of the current is about half what the swimmer knows he or she can do with respect to the water. And so the triangle that we have is a vector like this that may equal, say, 1 unit, and a vector like this that equals half of a unit. And so the question is, what is the net result? So you know it has to be less than what the person can swim at, because of course they have to keep making this motion against the current for every bit that they're actually going across the river. And so this really, once you get it set up, is just a simple Pythagorean theorem problem. So 1 squared equals 1/2 squared minus question mark squared. And so 1 minus 1/4 square root is question mark. And so this is root 3 all over 2. And so the net speed, the total speed of the velocity of the swimmer with respect to the land is square root of 3 over 2 times the velocity normally swimming across flat water. So this is a number that's bigger than 1. No, hold on. This is a number, this was 4. This would be a number that's bigger than 1. So this number is smaller than 1. And so because the speed is less by this amount, if the swimmer could just swim across a pool that same distance, they'd be swimming at a faster speed and so a shorter time. So the time it takes by a factor of root 3 over 2. So I took a moment to plug that into my calculator, and that is about 87%. So the reasoning is the distance hasn't changed, but the net speed is slower. Okay.